All right, one other thing I want to just mention. Oftentimes when you're doing a homework problem, they'll have something like this. Let's see. So let's say, so this is our vector, right? Let's say it's 30 degrees. Okay, so they'll give the direction of this vector in the following way. They'll say that this vector is 30 degrees north of east, okay? 30 degrees north of east. And you know, the first time you see that, you might say, what? All right? So, but it makes sense though, right? So first you just point your arm in the east, right? This is east, you know, east, north, south, west, right? So east, and then we go 30 degrees north of east. Okay? They also could say, for this same thing, they could say, okay, that's 30, this is 60, right? So they could also say 60 degrees east of north, right? Right? So there's north, and they go 60 degrees east of it. All right? So, you know, you'll see that kind of words when you do your homework problems and maybe your test questions or something like that. Okay, so the rest of this chapter is just examples. But you know enough now to be able to do these, okay? So, all right. So I would like you to read this and pause your video, and then you figure it out. All right? Absolutely do not look at the answer before you do it yourself. You have to learn how to do this yourself. Okay, so do it. All right, I assume you're back. So let's talk about it. All right, so it says find the components of vector B that are parallel and perpendicular to the tilted line. Okay? So here's vector B, right? Here's vector B. And we want the components that are perpendicular and parallel to this tilted line. Okay? So that, all right? So look. So, you know, so here's the tilted line. Okay, so here's vector B, right? Here's vector B. This is the component that's parallel to the tilted line, and this is the piece that's perpendicular to the tilted line. Okay, so let's do it. All right, so let's say B parallel. Okay, so again, here's B, and this is parallel. So what's that? Adjacent or opposite? Well, it's adjacent, right? It's adjacent to the 20-degree angle, so that's a cosine. So B parallel is like what we would normally call BX, but we don't want to do that because there's no X and Y here, right? So B parallel is just B, you know, which is B, right, times cosine of the angle. Now B is 4, so it's just B, so it's just 4 cosine 20, or whatever that is. I don't have my calculator. All right? And what's B perp? And we're just getting magnitudes, you know. So B perp, okay, here's B perp. So it's adjacent, agree? It's adjacent to the angle, so it's a sine. So B perp is just B sine theta, which is 4 units times a sine of 20, whatever that is. Okay, that's all. So you just got to be able to do those. You'll see when we start doing force problems, we do that all the time. All right. Oh, there's my whatever. Oh, hey, there, got the answers for you. What do you know, huh? All right, so 4 cosine 20 is 3.76. 4 sine 20 is 1.37. Okay, great. All right, so there you go. Okay, now this is a homework problem, and I want you to do it. If you could work with other people, that would be great, but anyway. So here's our coordinate system. And I don't want you to tilt coordinate axes, all right? Don't tilt them. This is practice in getting components right. And so here's this vector A, here's this vector B. So what you're supposed to do is find vector D. Vector D is 2 times A plus B. And make sure you write your component in I, J, K notation. That means you're going to be, finding angles, right? In trig functions, sines and cosines of angles, so you really need a calculator. Okay? So pause your video and work on it, please. All right, so I hope you've done it. Okay, so let's do it. Let's check if you did it right. So vector D is given to be 2A plus B. 2A plus B. All right, so in order to figure out what it is, we've got to figure out what A is and what B is, right? So we'll do that. So vector A, all right, so vector A, so, hold on a second. No, okay. So vector A, so this is the x piece, and this is the y piece, right? So we just resolve this vector A into a piece that's parallel to the x, a piece that's parallel to the y. I could write on the screen, but they'd fire me, right? Okay, so A, okay, and the magnitude is 2 meters. Okay, so it's 2 meters. And then, okay, what's the I piece? Remember, we're going to do this IJK notation, right? So the I piece is opposite, so a sine. So it's 2 meters times a sine of 15 degrees. And again, so, here's that, right? So it's, right? It points this way, agree? Because we want this up to the right. So it's 2 meters times 15 in the positive I hat direction. And then we want the y piece. So it's plus 2 meters. That's adjacent, so it's cosine 15 degrees. And it's in the j direction, right? J hat direction. Okay? And I worked it out, and it's 0.52 meters in the I direction plus 1.53 meters in the j direction. All right, how about B? Well, this is the bx, right? Positive. By is going to be negative, right? Or negative j, So this cosine, that sine. So vector B is 4 meters times cosine 15. And that's in the I direction. And then remember, the j is in the negative, right? So it's negative. So we write minus, right? Minus 4 meters. And then it's sine 15 degrees in the j direction. Now, by the way, there's more than one way of writing this, right? You could have actually written plus, and you could have written here minus j. I mean, who cares? It's the same thing, right? It's the same thing. So let's just do it this way. But again, it doesn't matter, And I worked that out, oh boy, really small, 3.86 meters in the I direction, then minus 1.64 meters in the j direction. So then we just want to do this. So, okay, so we have let's do it down here. So D, we have 2A, so I'm just going to use this, right? So we have 2 of those. So we have 2 times 0.52 meters in the I plus 1.53 meters in the J. And then we want to add the B, right? What? Oh, no. Then we want to add the B. So we want to add 3.86 meters in the I minus 1.64 meters in the J. Okay, Now, just like we did before, you know, you add your i's and you add your j's. So that's all. Let's do it. So can I erase this? Okay, so what does that equal? All right, so you add up all your i's. So you have add up all your i's, right? So you have 2 times. By the way, when you're doing this for real, you're not going to. You're not going to show every single step. I'm just doing that. I don't know why, but I am. So 2 times 0.52 meters. Then we have plus 3.86. Then we have plus j. And we have 2 times that. And then minus that. Oh, I forgot my meters. Oh, I did. All right? And then finally, you know, what do you get? So that's like 1 plus that. It should be like 5 or something like that. So it's 4.9 meters and plus j. So you get that. So it's like 3 minus that. So it's like 1.5 or something. No, it's 5. What? Wait a minute. Did I do something wrong? Oh, I did something wrong. How did I write 1 point? It's supposed to be a 9. Dang it. It's supposed to be a 9. Sorry. Okay, so that's like 2. So 2 times 2 is 4 minus 1.5 is like 2.5. So 2.82 meters. All right? And that's the answer. Okay, so that's D. Yeah, you can write the I before or after. It doesn't really matter. Okay, so that's the answer. So 4.9 meters times I plus 2.82 meters times J. Okay? So that's what you do. If you write it nicely and neatly, you won't make mistakes like I did. Now, we're not done yet. All right, so we did what the problem said, right? We found vector D in terms of components, you know, like 5i sort of plus like 3j, okay? Too bad that we didn't have graph paper, you know. We could, we can multiply this. This is A. We can multiply it by 2, and that would be up here. Then we could add it and just see what it looked like. That would be a nice way to check our answer, right? Just add it graphically on a piece of graph paper, but can't do that. What's the magnitude of D? This is the vector equation for D, right? What's the magnitude? So some people think it's this. Okay, this is wrong. What I'm about to write is wrong. All right, so here, that's the vector equation, right? So some people do this. Magnitude of D equals that plus that. Totally wrong. All right? So how do you find the magnitude of a vector? You just use Pythagorean theorem. So the magnitude of D, that's how we write it, absolute value, you know? It's just dx squared plus dy squared, square root of, which is 4.9 meters squared plus 2.82 meters squared, square root of. And you do that, and you get 5.65 meters. And then let's say you want to find the angle. Which angle? The angle relative to the x-axis. So, you know, how do you do that? We did that before, right? And so theta is equal to tan inverse of dy over dx, right? Opposite over adjacent. So it's tan inverse of 2.82 over 4.9. You do that, you get 29.9. There you go. Okay. All right, that's really all there is to it. So you better know how to do that. Like if I call you up in the 3 o'clock in the morning, you should be able to do it in 5 minutes. All right, honestly, you just have to know how to do these vector problems. Bing, 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 bing. Okay, here's another one. So again, all right, so hold on. So the position of a particle as a function of time, so r, the position as a function of time, is given by this crazy equation, right? And we're going to assume MKS units, which is nice because it kind of, we don't, all right, so no, we don't have to write units, okay? Just assume MKS units. So we want to know the distance from the origin at 1 second, the velocity as a function of time, and then the speed at time equals a half a second. So you can do this, all right? You know how to do this. Remember, position, well, I mean, there is the position. How do you get velocity? It's the derivative, right? The first derivative of the velocity, okay? So once again, pause your video and figure it out, and then we'll go over it. All right, let's do it. Okay, so we're given that the position as a function of time is 6I plus 5J times T squared plus 2I plus J times T. Okay, so the first thing, just put in 1 second. Okay, we can do that. So therefore, R at 1 second, so you just put in 1. So 1 squared is 1. So you have 6I plus 5J. Then you put here 1, so you get plus 2I plus J. And what does that equal? So you have 8I plus, right, so plus 6J. Okay, so that's the displacement, but the question didn't ask for that, right? It wants to know the distance from the origin, because what does this look like? So I mean, it's, 1, 2, 3, 4, 5, 6, 7, 8. So we go that way, and then we go up 6. So 1, 2, 3, 4, 5, 6, right? Right? So what's the distance from the origin? It's this, right? It's that. So if this is 8I and this is 6J, what's this? Just Pythagorean theorem, right? So this here is just 8 squared plus 6 squared, square root of, right? But this is just a 3, 4, 5 triangle, right? Times 2. Agree? And so it's just 10, right? Because 8 squared is 64, 6 squared is 36, 100. Square root of 100 is 10. But again, what I want you to start recognizing, though, 6 is 2 times 3. 8 is 2 times 4. So this is just a 3, 4, 5 triangle multiplied by 2. So you don't have to do all this monkey business. Just look at it and say it's, it's a 3, 4, 5 triangle times 2, so it's 10. I mean, you should be able to do that. Okay, so the distance is 10, right? So that means that we would write that like this. We would say R at 1 second, magnitude is just 10. Okay, 10. All right, then we do the velocity. Well, if this is the position, how do we get velocity? Just take the derivative, the time derivative. So velocity as a function of time equals dr dt. Okay, what's the derivative here? There's a t squared. What's the derivative of t squared? Just 2t. So you get 6I plus 5J times 2t. And what's the derivative of t? It's 1. So you get plus 2I plus j. Okay? So that's it. All right? I mean, you can multiply it out if you felt like it, but I mean, that's it, And if you want to, you can put the 2 here instead of there. Whatever. It doesn't matter. Okay. Now what we want to do is find the speed at a half. So we want the velocity at a half a second. Half a second. Okay, so 6I plus 5J. Okay, what's 2 times a half? 1. Isn't that nice? 1. And that doesn't have any time, so we just do it. Write it down, 2I plus J. Okay, how many I's do we have? We have 6 and 2. We have 8I. How many J's do we have? We have 5, 6. 6Js. Okay? But that, they didn't ask for the velocity, right? That is the velocity, you know, vector, because velocity, magnitude, and direction, vector, right? They asked for the speed. Well, we can do this in our sleep now, I hope, right? I mean, yeah? So we already did it, right? So here's an 8I plus 6J. Here's an 8I plus 6J. So the velocity at a half a second, magnitude is 10 meters per second, you know, 10, okay? It's just, again, it's just that squared plus that squared, square root of. All right, now I want to show you something else that you're going to use a lot in lab. And this sometimes drives students crazy, so pay attention. All right, so this is a position, right? A distance. So this is in meters. So what does this have to be? Has to be meters, right? What does this have to be? It has to be meters, you know? Okay, so in order for that to be true, these numbers actually have to have units. Yeah? Yeah. All right, here's why. So here. And here's why. I mean, look, this here is time squared. So it's seconds squared, right? But wait a minute, we want this thing to be meters. So what has to be the units of the 6 and the 5? So the 6 is really 6 meters per second squared times I, and the 5 is really 5 meters per second squared times a J. So I'll do it like this. I'll say plus J, put a little I there. All right? So what I'm saying is, you know, we don't usually bother writing it, but the 6 really has units. Okay, does it make sense? Well, look at it. 6 meters per second squared times second squared. That kills that, and you get 6 meters. Has to be in meters, right? 5 meters per second squared times second squared is killed, you get meters. So these numbers have coefficients. So like in lab, you know, you're going to be making some graphs, and you're going to be figuring out slopes and all sorts of things. And, you know, Excel is pretty smart, but not super smart. And so Excel doesn't know the units. I mean, that's what you have to figure out. So when I ask you, you know, what is the slope of this line, you can't just say 2. You know, you've got to give me the correct units. Okay, let's do this one. So this one, you know, we have 2I plus J times time, which is in seconds. But again, the whole thing has to be meters. So you can tell me now, what has to be the units of 2? We want meters, but we got to kill off those seconds. So the 2 is really a 2 meters per second. This is a 1. What's the 1 here? It's a 1 meter per second. Because when you multiply that and that by the seconds, and you just get meters. So you notice that these have different coefficients than these, right? These were the coefficients were meters per second squared. These are just meters per second. So you'll talk more about that in lab, but I just want you to see it in class, you know, so you don't freak out, okay? Okay, so again, this is important, right? This units of the numbers there. Not going to do that, not going to do that. Okay, so here we go. Let's summarize. So basic properties of vectors, magnitude and direction. We know how to add and subtract graphically. We did that a while ago. Now, if it's written in terms of IJK, it's simple, right? Just add and subtract. We know how to decompose a vector in components and then how to reassemble it. You know, just components, right? Either cosine or sine. Then we used for the magnitude, Pythagorean theorem. For the directions, usually inverse tan, if you know the components. Basic unit vectors, just nice IJK, right-handed coordinate system, don't forget. And tilted coordinate systems. We'll get a lot of practice with that later on. Oh, I don't want to do that. Let's forget it. Let's do it. Let's not be lazy. Okay, so this is practice for you, all right? So pause your video and do every single one of these, please. You really have to be expert at this. Oh, yeah, that's a good one. Okay, I just realized I forgot to show you something. Well, it's not a big deal, but so typically when you add, let's say I have a vector A and a vector B, so that the way that we've learned in the past to add these is head to tail, right? Head of A to tail to B. So we just, okay, let me start over. Let me start over. Here's a vector A. Here's a vector B. So what we've learned in the past is at head to tail. So there's A, there's B, right? Head of A, tail to B, and then we go from the beginning to the end, right? A plus B. Now that's one way, but there's another way. It's called a parallelogram method. So here's a parallelogram method. So instead of putting them head to tail, you put them tail to tail, okay? So there's A, there's B, sort of, kind of. Then you just make a parallelogram out of it, and you go from here to here. Ta-da! A plus B. And you can see, isn't that exactly the same as that? Yeah. I mean, here's another example. Let's say I have an A like this, and a B like that. Okay? Now again, you can do it head to tail, not a big deal. Head to tail, there's your A, there's your B, so bingo, right? A plus B. But you can do a parallelogram if you felt like it. You don't have to, but you can. So you just do it here. Crummy. Then make a parallelogram, whatever. There it is. And so so there's your A plus B. So that's the same as that, right? Now, whichever you want to use, it doesn't matter. Just, it depends on the problem. Okay, so like for this one, I mean, they're already joined at the tail, so I would just do a parallelogram method. Why not? All right, so everybody, so pause your video and figure it out, please. Okay, we're back. So here's A, here's B. It's the parallelogram method. You just draw your parallelogram with dotted lines. Go from the intersection of the tails out to here, A plus B. Woohoo! Okay. And just for fun, what did I do? I did it head to tail also, just to show you. It's the same. So here's my vector. Here's A, right? Here's A. Here's B. Here's B. So I did it head to tail from beginning to end, and I get this. So isn't that exactly the same as that? Yeah, sure is. Okay, then let's do the subtraction. So A minus B equals A plus a negative B. All right, so here's my A. Here's my A. Then, okay, if this is B, negative B points this way. So there's my negative B. So I did it parallelogram, right? So here's the tail of A. Here's the tail of minus B. Draw your parallelogram. Bingo, right? There it is. I also did it head to tail. So here's my A. Here's my minus B. Just go from beginning to end, A minus B. Yay! So whatever you like. Okay, and here's 2A minus B. Okay, so parallelogram. So here's an A, here's another A, so there's my 2A. Okay, B was pointing down, so minus B is pointing that way. So then you make your parallelogram, and there you go, 2A minus B. Okay, head to tail, 2A, then the minus B, beginning to end, same thing. Okay, what is C plus D? Well, however you want to do it, right? I think I would just do it head to tail. You just put this right here, just go from the beginning to the end. All right. I did it both ways, whatever. Okay. So, all right. So here's D. And C is like that. So what do you want? Yeah, okay. So head to tail, here's my D, or sorry, here's my, let's see, here's my C. So I did C plus D, right? Here's my C, then here's my D, then you go from the beginning to end, C plus D. Here's my D, here's my C, so tail of D, tail of C, parallelogram, bingo. And that's it. See you later.